9. Ignition sequence start. 6, 5, 4, 3, 2, 1.
Hello, welcome to the first T-Talk of 2022, brought to you by Telespazio, and it's the first T-Talk in English. I'm Richard Hollingham. I'm a UK-based science and space journalist and presenter of the Space Boffins podcast. And tonight, we're going to feature some of the new generation of space explorers, engineers, and look ahead to the future of space exploration, both in orbit. We're going to be talking about cleaning up space and return to the moon with a spacecraft small enough to hold in your hand. Feel free to ask questions to any of our guests at any time. You can get in touch via Twitter, YouTube, and LinkedIn. And let's start with those young innovators that I talked about. I'll introduce them first. 3 of the 2021 T-TeC winners. We've got Alessandro Lotti. You can give a wave, Alessandro, if you want. That's Alessandro. You can see there in the corner. Hi, Alessandro.
Hello, and good evening to everybody.
We've got Tomas Boschetto as well. Hi, Tomas.
Hello, how are you, everyone? Thank you very much for having me here. It's a pleasure.
And then we've got David Gonzalez as well. Hi, David. I'm trying to work out what's in you. Oh, I thought you were at a weird angle, then I realized your bookcase was at a weird angle. That's what's going on behind you. Hello, okay. David.
Hello, Richard. Hello, everyone. Good to be here.
It's great to see you all. We'll come to your projects in a minute. We're also joined by Stefano Beco, Head of Technology, IPR and Product Policy at Telespazio, and a previous participant in T-TeC, Alessia De Matteis, who also works for the company. Well, let's start with Stefano in the corner there. Let's talk a bit about T-TeC first of all, Stefano. What's T-TeC? What are you trying to achieve with it?
Right, thanks, Richard, and good afternoon, everybody. Well, T-TeC is the way. T-TeC means Telespazio Technology Contest. It's the way we started to, let me say, to face the open innovation in a wider and more complete way in 2019. You know, I'm a scuba diver, and when we go underwater, there is always something that could go wrong. So the first thing that we have to do is stop, breathe, think, and then act. This is what we did in 2019 when we wanted to achieve better results from the open innovation. You know, open innovation is a buzzword. Everybody is talking about open innovation here and there. And we wanted to do something better than just making agreements one-to-one with some university or research centers. So we decided to invent this contest. The first edition was participated by invited universities and research centers, because we started with, let me say, with friends, with all the people we were already in touch with at that time. The challenges were related to what is in our technological plan in terms of technological themes. So which are the themes, the challenges we want to face for the next future? And so we asked to young people, researchers, graduates, and also some professors that help the students to participate, what they have in mind, how do they want to tackle some of these challenges.
So give us some examples of the. Sorry to interrupt. Give us some examples of those sorts of challenges.
Yeah. For example, I can give examples of the challenges of 2021 because things were growing up. This year, we challenged all the participants and all the 3 winners that we have here today on space exploration. You know, we are now going back to the moon. We will go sooner or later on Mars and maybe beyond. So space exploration is one of the key issues, key technological issues that we as Telespazio want to go towards. Then, in orbit servicing, we are, let me say, polluted by a lot of space assets, a lot of satellites. And if we want to make the best out of the satellites that are already there, we have to be in the position to serve them, to repair them, to maintain them, to refuel them, to move them here and there, and to also remove from the orbits when their life is ended, or when their movements could be of some danger for some other space assets. Then another.
And really, this is about sort of moving away from the Earth and looking at a sustainable use of space in the broadest sense, I suppose.
Indeed. This is also to make it even more sustainable. To do this, we also need to have a space traffic management, and this was another of the four challenges we gave. So systems to manage in the best way the space traffic. You know, space is going to be very, very busy. A lot of constellations with hundreds and thousands of satellites are already launched and are going to be launched even in the future. So we need to understand how to manage all this traffic. We need some tools to do that, and also to have a better and very good surveillance of what is in the sky. So an awareness of what is running out in the sky. Then the fourth and last challenge was related to the geoinformation applications. As Telespazio, you can see from the picture behind my shoulder, as Telespazio, we are also processing Earth observation data to provide valuable information and valuable higher level data. But we can do even better using artificial intelligence and things so on. And this is what we also ask to the students and to the participants.
Okay, we'll talk to them in just a moment. I've just got Star Wars tat behind me on the on the shelves here. Let me come to Alessia first of all, though, because you took part, Alessia, in T-TeC in the past, and now you've got a job with the company. So just tell us a little bit about how you ended up doing what you're doing.
Yeah. Hi, Richard. Hi to everyone. Yes, exactly. I took part of the first edition of the T-TeC. After my graduation, I proposed to candidate my thesis work at the contest, and in that case, I don't won the contest, but this participation brought me in Telespazio. And after research scholarship and a second level master in satellites and orbiting platforms, I started to work in this company. Right now, I'm working in a lot of interesting projects. For example, the main project where I'm involved is an ESA founded project within the Moonlight program.
Now I'm going to stop you there because I want to hear about that later on. We'll come back to Moonlight, because Moonlight is very interesting. It all feeds into this sort of going to space and staying, if you like, going to the moon and staying. But let's get on to these ideas that won the latest T-TeC, and then we'll get back to space exploration and space sustainability. Alessandro, let me come to you first. Now, your project involved a modular satellite. I mean, not massive, sort of CubeSat size satellite. Tell us a little bit about it, because it's quite an interesting idea.
Yeah, sure. So, as you said, our project, which is entitled the Multipurpose Modular Satellite Servicer, consists in the concept for an innovative mission platform, for a microsatellite platform, to provide in-orbit servicing in low Earth orbit. So as you said, it consists of a modular spacecraft. We conceived 3 main units. The biggest one is intended for refueling, for providing refueling, while the other 2 are dedicated to signal relay in case of failure of the radio frequency system of a target, and to provide other kind of services like system reprogramming and the tumbling, and even diagnostic. So when we started working on our project, we started from a problem which is related, as Stefano said before, to the sustainability of space from the point of view of the need to be sure that in the future we will be able to access space, so to reduce the number of debris on one side by extending satellite lifetime, to make them more profitable from the economical point of view.
So is it like a break? So is it like a breakdown service for spacecraft? Is that sort of servicing breakdown, kind of roadside assistance, if you like, for spacecraft?
Yeah, actually, the modules are intended to work together if needed, or even independently. And our idea at the beginning was to provide service, for example, to a constellation. So in case it would be maybe more easy to switch from one satellite to the other at the end of a servicing mission.
That all makes an awful lot of sense, doesn't it, Stefano? When you're talking about, I mean, also, but the cost of satellites is enormous. If you can keep them up there longer, and particularly we're now talking these mass constellations of particularly communication satellites, but we're seeing that with presumably in the future with Earth observation satellites as well.
Yeah, indeed, especially satellites that are not of the latest generation. They are quite big. They bring a lot of added values, of course, because they have a lot of payloads, they have a lot of instruments on board with higher resolution with respect to the CubeSat or SmallSat that they are launching today. But exactly for this purpose, and not to have too many debris, whatever they will be in the future, an approach like the one from Alessandro and his team is exactly what we need to have a life extension that means to let them last more in a better way, maybe replacing also the sensors to have a newer generation sensors to make even better their work, and not to pollute the sky, in fact, not to pollute the space.
And let's come to you, Tomas. I think we could talk a bit more about space sustainability in a second, but you were from the team that won second prize, and you're looking beyond Earth to the moon. And again, describe your project, but I think you need to give a sense of the scale here, because you're developing a moon lander. Now, we've seen pictures of moon landers. We've seen maybe the Soviet landers that landed on the moon, those enormous sort of wheeled vehicles that the Soviets landed. Of course, people on the moon, these big, giant moon landers. And even the most recent, the Chinese mission that landed on the moon with the rover. Yours is tiny in comparison. So talk us through.
Well, thank you very much, Richard, for the question, for the insight. It is truly that way. Missions to land on the moon and other planets tend to be very complex and big in terms of volume, of mass, and also very costly. And those are all a set of issues that we're trying to tackle with our approach through a revolutionary type of technology, a novel mechanical approach to the maneuver of landing on another celestial body. We believe it has the potential of enhancing our presence throughout the solar system, because when we think about the mission of go to the moon, to visit another celestial body, we look at huge numbers and a great amount of technological complexity. And we think that by making it simpler and more cost effective, we could enhance our presence throughout the solar system.
So your lander, let's get it straight, is a CubeSat. So it's tiny, and you're talking about lots of landers. Is that right?
Exactly. Yes. We, as a demonstrator, the first step that we see in the pathway of our project is to carry a small payload to perform a small landing on the moon. The landing in this occasion will be attached to to a 3U CubeSat. But in the future, we envision the idea of deploying thousands of them at the same time and potentially serving to deploy infrastructure and equipment in a timely manner and, as I said before, in a cost-effective way.
What's the point of tiny landers? What can you do with small landers?
Well, the thing is that even though the size of the lander is scalable, the technology, the tensegrity technology enables this fact. We could potentially, I don't know, put a machine inside the lander, and imagine if we would go to drill on the moon, or if we would go to deploy an antenna network there, we could carry the entire equipment inside the tensegrity. But if we would have many of them, we would expand our possibilities of deploying more cargo and taking away mechanical constraints out of the structure.
Makes a lot of sense. Okay, let's go to our third T-TeC winner, and that's David. I'm going to have to read this because your project's called Estate. This stands for Electromagnetic Skins in Metal by Additive Manufacturing. I mean, it is a bit of a tortured acronym, but it's it's a really neat idea. So you essentially talk about satellites that we know satellites you can now reprogram them in space, but this is actually physical changes on physical adaptations you can do in space. Is that right? Have I got that right?
Yeah, absolutely. Well, just to complete on the acronym, actually, it's I didn't invent it. It's estate. It's in Italian from my Italian colleagues in the team. It means summer in Italian.
Oh, that's much better. So, brilliant.
It's not so complicated. So yeah, so right now these electromagnetic skins that the way we are using them right now is as antennas. One of the main payload in any satellite is the antenna. So we want to sort of look at the global problem in a different way and exploiting in a manner as efficient as possible the available surface and volume to accommodate new payload. And in the last instance, our goal would be not only to use more efficiently the bus or the satellite to accommodate new payload, but also being able to dynamically reconfigure these electromagnetic skins. We are not yet there, but our team from CNRS, University of Siena, and many other teams around Europe and the world are working on that, on reconfiguring these electromagnetic skins or metasurfaces, if you wish.
So actually, the space, it would change. So the skin of the satellite would change, or you can change it. Essentially, you can change the configuration of your antenna system while it's in space, and you don't even need one of Alessandro's servicing satellites to do it. You can do it just by sending a command up to the satellite.
Yeah, that would be the idea, to use either electronic reconfiguration, which has some advantages in terms of avoiding complex mechanical movements, but even mechanical reconfiguration would be an option.
Excellent. Well, let's continue with this theme really of sustainability, of being able to change things in space, service things in space. Stefano, I mean, we've seen, I guess, with the when we used to have the space shuttle, you could go up and service. We've seen famously servicing Hubble, of actually bringing satellites back down to Earth. But this is on a whole different scale, and this doesn't involve astronauts. You can do it all either by sending a command like David's concept, or actually having satellites that do this for you.
Yeah, exactly. The goal is to have an autonomous tag or autonomous truck that is there and can make different services during the tag's lifetime. So the tag itself can reconfigure its mission in order to refuel one asset, one satellite, or maintain and check the status of another one, or replace an antenna if you are not able to change it via a telecommand like David is and his team are doing. So the goal is to send, yes, indeed, is yet another satellite, but it is there to serve other satellites. So it is not something that is fire one and then forget, but it can be reused, it can be remissioned while in space. And this is another thing that is going towards the sustainability. We don't need to send one track, one tag for each service we have to do, but we send one that is enabled to do different services. Not all of them. Maybe some of them will be specialized, some of them will be multi-purpose, but the goal is to have a sort of, as I said, tag that are there to be helpful.
Alessandro, then, who services your satellite? So let's say you get it built, you've got this modular satellite. What happens when it runs out of fuel? Do you have to have a whole infrastructure in orbit? Do you have to have sort of fueling stations, gas stations?
Yeah, actually, this can be done. So it's possible to refuel the spacecraft. Actually, when we worked on the project, we also provided the option to reassemble the modules in case there is the need to perform an expensive maneuver that could be done all together by exploiting the fuel carried by the largest module. And then if the whole mission run out of fuels, it's possible on one side to refuel all the modules with another mission, or maybe it would also be possible and interesting to study eventually to build sort of refueling station, orbiting station in space, so that we don't need actually to launch another satellite, but maybe to perform a shorter mission from such station to our servicing satellite. So this is clearly an option to be studied for the future.
And Stefano, for this to work, and you also talked about space traffic management, you've got to have companies and space agencies and governments really working together to make this happen. It can't just be Telespazio doing it.
Yes. I mean, as Telespazio, as a company, in our mission is the one to provide services related to space. So this will be one of our future services. We are already working on that. But apart from us, we are not alone. Agencies, space agencies around the world, but also governments are thinking about how to manage this traffic, are thinking about also how to make the traffic management seamless management from ground to space, because we have a lot of assets, a lot of drones, airplanes, high altitude platforms that are moving from the ground and reaching higher levels or the space. And this is something that need to be tackled all together, need to be managed all together. And a lot of agencies, as I said, and a lot of governments are thinking about that. Of course, there are two different purposes. One is to manage the traffic, in fact, like we do for the air traffic. And the other one is more related to the defense, let me say. I mean, we need to have the space safe and secured. That means that we have to have a clear understanding, a clear awareness of what's going on, to have a complete space domain awareness, and to have also the means to make measures in order to react to potential attacks or potential mismanagement, let me say, of assets.
And David, with your technology, again, it feeds into this idea of lasting longer. So could you combine your technology with the sort of servicing technology as well? You know, if you had a serviceable space satellite that can be reconfigured in space, I mean, that could potentially last decades, couldn't it?
That would be a great application for this technology. Exploit the reconfigurability of the payload to, in case of necessity, provide the satellite a new function, or adapt the characteristics of in this case, for instance, the antenna to either a new orbit or a new application. Why not?
And I mean, Stefano, how do you take these projects forward? Because these are ideas, like you say, that Telespazio is already looking at. I mean, how will these projects become a reality, or these sorts of projects become a reality?
Well, what we are starting doing is to analyze the roadmaps of the three winners, and this is exactly what we started in Dubai. In fact, just after the award ceremony, we got all the teams together and say, look, now what we want to do is not just to give you a prize that you deserve, but we want to make, let me say, business with you. I mean, we want to let you grow because we are interested in that. Consider that the evaluation committee was composed by a lot of colleagues from Telespazio, from all the world, but also from Leonardo and from European Space Agency, Italian Space Agency, and United Arab Emirates Space Agency. So it's not just us that decided who is the best, but there is an interest also from the space agency. That means that there could be potential future for all of the winners. So we are now in the, let me say, in the stage of understanding their roadmaps and trying to understand how we can help them to help us, in fact. Maybe getting them in touch also with some other companies of our group that are more interested in one particular thing or the other, but all in all, to make the whole ecosystem, let me say, space ecosystem growth, thanks to the collaboration with the university. This is the key of the open innovation, whatever it means.
And I suppose, ultimately this idea of space sustainability, I mean, it sounds like a thing that's going to cost, but actually it's a thing that you can make money from, because it is inevitably going to be the future. All these things, there is a market there to develop these technologies.
Indeed, there is a market. The market is growing. The more satellites will be in orbit, the more this market of sustainability will grow as well. Being sustainable in the space is not just taking care of how many satellites you launch, the orbits, just to make them flying one apart from the other in order to avoid collision. Yes, this is also another aspect. But to make it sustainable means also to serve the people on the Earth without polluting from a light point of view. I mean, there is a lot of things, a lot of people keep saying there will be a lot of satellites that will mask the stars. We will no more be able to mask the stars. They are working on making some sort of, let me say, invisible satellites in order not to mask the brilliance of the star. But then make it sustainable means to try to find the best way to remove debris, to find the best way to cooperate in terms of in-orbit servicing and things like that. So these are all different market segments, let me say like that, for which companies like Telespazio, but again, we are not alone in the world, can make services, so make business on that. So sustainability is a business, but it's a positive one. This is what I'm really convinced of.
Okay, let's move on to the moon. I promised you talk about the moon. In fact, we've had a question about the moon, which I'll come to in just a second from Twitter. If you've got any questions, do get in touch. Twitter, LinkedIn, YouTube, I think, all over the place. It's not difficult to find us. It's really not. So I'll come to that question in a minute. Let me come to Alessia, because I sort of teased that you've got this this mission you're working on. Tell us about what the mission is and what you're aiming to do.
Yes, the mission is a mission founded by ESA within the Moonlight program. And the aim of this mission is to, let's say, design and study the feasibility of building an infrastructure to offer communication, both communication and navigation services for the future lunar missions, and in general for the future space exploration.
So that's the same way that we have satellites in orbit around the Earth providing communications and satellites around the Earth providing navigation. Yes. You'd have these satellites in orbit around the moon.
Yes, exactly. In fact, right now we are analyzing which are the best designing for build a robust constellation around the moon to offer those services. And the aims is to build a constellation like for the navigation, for example, like the Galileo or GPS around the Earth.
So Thomas, the obvious question is, this is going to help you, isn't it? If you've got your landers, you've got a navigation system, a communication system. This is kind of starts to tie all together, doesn't it?
Of course, it could be a symbiosis. In fact, we believe that a kind of mission such as Alessia is describing could need a huge amount of infrastructure and support equipment on the ground to function well, right? And on the same side, our mission would be greatly favored by an initiative which provides location and location services and communication services.
And yours, again, we talked about sustainability in Earth orbit. I feel I'm overusing the word, but it is about sustainability on the moon too. And the idea of yours, presumably, if yours became a reality, you could just keep operating these missions, these small landers, bringing materials, bringing supplies, whatever you wanted to do.
Yes. The thing, our sustainability approach has to do with achieving more with less resources, less use of time as well, to achieve simpler, faster, and more trustworthy missions. And we believe that this could favor a responsible use of the resources, not only in the moon but in space in general. That's the idea, making responsible use of resources to achieve as much as we can with as little as we are able to employ.
And Alessia, with these communication and satellite navigation systems, as you say, funded by ESA for the research to build up the understanding what's needed, what are the challenges of doing that on the moon compared to Earth? I mean, I followed, for example, Galileo project. It seems to be going on for ages before we actually got satellites in space. It was hard. It's hard to do this stuff on Earth. We know it's been hard. It's hard to do communications from space on Earth. But doing it on the moon is it's another challenge, isn't it?
Yes, of course. It's not simply work, but the aim is to gradually build a complex and fully functional infrastructure. So at the first time, we aim to build to bring to the moon the first module of this infrastructure, and then we hope to allow the interoperability with the other international project from the other space agency around the world. So it's a huge and challenging objective, but I think that together we could rise great results.
And would this be really about supporting humans on the moon? Because there's a chance that one of the first people on the moon or back to the moon could be Italian ESA astronaut Samantha Cristoforetti. So was this the idea, is to support humans on the moon?
Yes, of course. One of the objective is to allow future stable colonization of the moon thanks to those infrastructures. So to allow working on the surface, but of the moon, and also in the space environment. But yes, it's one of the reason bring us to study and analyze these.
Exciting stuff. Exciting stuff. I have a question for Alessandro. Alessandro, I think you guessed that this question was coming to you. You can also see the questions that are coming up. We talked about refueling in orbit. Talk about well, I suppose there's something missing maybe from this question. A refueling station on the moon is a real option? ? So I guess the question is, could a refueling station on the moon be a real option, and in how many years, if it is?
Okay, so yeah, I believe it could be an option, but basically we need to start from Earth orbit to validate the technology at least, and then it's always a sort of trade-off. So we need to study if that it's convenient from an economical point of view, because we know that, for example, on the moon we have less gravity, so everything basically changes with respect to the Earth orbit. The environment is really different, but it's certainly an opportunity to study when we are going to have such a constellation around the moon to provide positioning, telecommunication, and so on. This can also be an option to make it more sustainable.
So you could have one of your refueling satellites in orbit around the moon as well, servicing these spacecraft. Yeah, you've got a whole breakdown sort of network. You've got a whole huge potential business building up here with the sustainability of lunar exploration as well. Stefano.
So you know why we are setting up the T-TeC. This is one of the examples. Try to build in this sort of networking, because things are growing together, in fact. And if I can add something more on the refueling station on the moon, sooner or later there will be. I cannot say when, but as Tomas said, we need to do the best with the less, with the less, and that means that in order to make it sustainable, the moon economy has to start with a sustainable target, let me say, and not as we did thousands of years ago here on the Earth. And to do that, we need to not to bring everything from the Earth to there. Is much expensive. Is not the optimal thing. So we need to start building things on there using robots or whatever sort of small rovers. It's a sort of Internet of lunar thing, let me call it like that. There will be a lot of things together, autonomous, working alone, but working together as well, working on the moon, but in touch with the Earth, and then communication and navigation satellites around the moon to allow them to link to the Earth. And then at that time, they need some fuel. They cannot be perennial, let me say like that. So we need refueling station there, also because when human will be there again, to stay there, not to go touch and go back, they again cannot bring gasoline or whatever sort of fuel from Earth. They have to find a way to produce it there from regolith or from other sources that are there. We are studying this. The lunar economy is exactly dealing with that. It's exactly targeting to these things. When? Well, we cannot say now. 20 years, maybe. I will not see. Maybe the young colleagues that are here will do it.
And you mentioned, it's an interesting phrase you just used, because you used to talk about the moon economy, the lunar economy, and having this idea of actually doing what we've done around Earth, but in the moon, but hopefully a different way and a better way. But we've seen that with obviously with around the Earth, with missions led by space agencies to start with, and then the rise of the private of space companies and purely commercial ventures. So not just ventures supported by space agency, purely commercial ventures around the Earth. Do you think we'll see the same then with the moon? That it will become a sort of commercial environment. There'll be, I suppose, money to be made. Definitely.
This is the way. I mean, there is not another way to do it now. Of course, we need the institutions and the agencies putting their willingness, their ideas, and their money together to allow the whole, let me say, knowledge, not the knowledge of just one nation or one agency. So the knowledge has to be spread around. Then, whenever you start having a common knowledge, a common baseline, then you compete from a business point of view. So there will be commercial opportunities and commercial industries and privates that will do that. Will launch new robots. Will launch people, and we see, you know, that the NASA programs for the International Space Station is to, okay, now it is prolonged for some more years, but then at the end it will become a commercial station somehow. We know SpaceX, they are bringing as private all the astronauts from the agencies. So I mean, this is the way, and there is no point in doing different on the moon. Starting with the right foot, starting with the right sustainability in mind, as I said before.
Well, that's what I wanted to talk about, because we're talking on one hand here about cleaning up space because of the mess we've made in orbit. And here we got this opportunity with the moon. How do we make sure we do it differently, that we don't make the same mistakes and just fling stuff in orbit around the moon without thinking it, or on the surface without properly thinking it through?
Taking the best benefit of what we have done wrongly, maybe on the Earth, and being sustainable by design. This is what we need.
Sustainable by design. Well, David, that's a good cue for you, and this idea of, you know, I mean, I guess, you know, combining all these ideas with, you know, Tomas, David, Alessandro, what we're talking about, Stefano and Alessia, is, you know, if you've got, that's what you're doing, isn't it, David? It's sustainable by design. You're these smart spacecraft that can reconfigure themselves, and I guess that would apply to landers. It could apply to lunar settlements.
Yeah, of course. I mean, we are a bit less ambitious, and we are just focusing on the on the antenna part. That's also the way in which our project is a bit different from those of Alessandro and Tomas, because they are proposing extremely nice mission concepts. We are focusing on a component, just a small part of the satellite, not the whole mission. The common thing that we all have, the thing that we all have in common, and I take the liberty of stealing a sentence from Tomas, because he said that during his presentation at the T-TeC, is that all the projects were about CubeSats. And Tomas said in Dubai, we are moving towards a democratization of space. And yeah, I totally agree with you that the three projects sort of come along together to this sort of
nice use of the phrase.
Doing more with less. Sorry, Tomas, I interrupt you.
So, Tomas,
no, of course. I was just saying that it was wonderful use of the phrase, and that I'm glad that we can match on that point, on democratizing access to space in general.
And Stefano, when you talk about democratizing access, the point, it's money, really, isn't it? It's the cost has come so far down that we can be talking about the possibility. You know, T-TeC, you've got these really bright people doing these things that can become reality. There's the possibility of these actually getting into space now, which even 10 years ago was pretty unfeasible.
Yeah, but in fact, the democratization of the space is now, it is a buzzword, but it is a reality. In fact, I fully agree with Tomas and David, because also from small realities, small companies, they can try and test something in the space, not just in the laboratories, and see whether it works, and can do it with not a big investment. But at the same time, there is a risk in this democratization. As far as everybody can launch, well, let me say everybody, in principle, everybody can launch a CubeSat to make their test. There will be a lot of CubeSat, a lot of small bits and pieces around the sky. And again, we go back to the pollution, as I called it before, of the space. It has to be done, again, in a sustainable way. There are rules, there are international rules that says that all the satellites have to, let me say, to end their life within a specific amount of time, without leaving debris, just re-entering according to some physical laws, so that will be burned out when re-entering the atmosphere. But the more are there, the more frequent could be that something is not going in the right direction. This is why we have to be ready to clean up the sky and to clean up the space, also with other systems, with other inventions. But nonetheless, as I said before, the sustainability is now a key, and is a key also for all the new missions, whether they are 1-ton satellite or 10-kilogram satellites. But of course, democratization is something that we all will get advantage from.
Well, let me come back to everyone in turn. And there's a question here from Twitter about how much interest is growing in universities in space-related subjects. I'll come to each of you in turn, maybe, around this sort of question, because I've certainly noticed a huge sort of change again. Maybe it ties into what you're talking about, Stefano, in this democratization of space. So many more people are doing space, so many more people are interested in space, and there are so many more opportunities in space. I mean, do you all sense that? Alessandro, I mean, how do you feel about that? I mean, you're fairly optimistic you can actually get your spacecraft to fly, that you've got the support, the interest there.
So first of all, I can confirm that the interest in space-related topics is increasing at universities, since I'm at university every day, since I'm doing my PhD, and much more students are enrolling since the past years in aerospace-related courses. And I believe that this is one of the benefits of investing in space and in general in the space economy. So fostering culture beside of knowledge is one of the advantages of investing in the space, together with the other that are fostering innovation. So as of today, we use in our daily lives satellite data every moment, for example, for positioning, for telecommunication, and so on. And the other one is, as we mentioned before, international cooperation. For example, the International Space Agency is an example of cooperation of different agencies of different countries. And so I believe that the interest that is growing at university is just one side of the benefits in continue to invest in the space field. Then I hope in the future we will see, as you said, our mission flying. So we are working to further develop our project that at the time of participating at T-TeC was a concept. So we started by putting together the expertise of our lab. And I believe there's a lot of potential in doing that. Even because actually in the future of space, I see a lot of non-space companies. So and I believe this is another aspect of democratization. So this let me think positively.
Excellent. Alessia, do you share those same positive feelings? I mean, you came into Telespazio, you got your job as a result of taking part in this T-TeC, and I know there are other opportunities, or there seem to be more opportunities, as Sandro was saying.
Yes, I completely agree. In fact, I think that in general, within an open innovation process for a company, is fundamental to interact with the academic researcher or a young student, because they are the glue between these two worlds, and that allows to the industry to make the really innovation and to make in practice the great ideas that coming out of the university. So,
and what about getting more women into space, or are there women? Are we just not always seeing them, perhaps?
yes, I hope that the women presence in these fields growing for the moment is not so so enjoying for us, but I hope that in some years the thing changes for everyone. And
yeah, absolutely.
I can
David,
give a figure on that, Richard. I can give a figure on that. Among the participants to the latest T-TeC edition, we have more than 25% of women participating. It's not 50-50, but it's really much better with respect to the past years.
Yeah, and it also is I mean, there is definitely a trend. I mean, just looking at the recent astronaut applications for the European Space Agency, again, they're heading towards sort of 25%, 30% or so women, whereas before it was like something like 10% or something. So it's the same. You know, it's hard though. I think is David. Do you think there is more interest in, within universities, within people wanting to do the sort of things that you're doing and seeing those opportunities there?
Well, what I feel, what I can see on a daily basis is that all the projects with a space application related to space are the ones where the students want to participate, where they want to. So for sure, space. I think it has always been the case for aerospace engineers. And I'm not an aerospace engineer. My background is in electrical engineering, but we have always wanted to participate in projects related to space. So I think that's always sort of been the case, but it's true that lately, maybe also because it's easier to access through the social media, the internet and so on, to a lot of information related to space. I do agree with Alessandro, with Alessia, that the interest is going up.
Yeah, it's interesting what you say about, yes, you're not an aerospace engineer. I mean, I'm a biologist, and I spend my entire time talking to space engineers and involved in space. So I mean, there is a load more. I think people from different backgrounds are getting much more involved, many more opportunities for space. Tomas, what's your view on this? Is there growing? I suppose Bars, is there excitement around that these projects, that your missions could actually happen? This isn't just something you're writing out on a sheet of paper, entering to a competition. There is a chance that actually this is the way space agencies are thinking. This is the way companies are thinking.
Yes. What I notice is growing interest in the interconnectedness of things. We are now seeing a revolution in industry, in society in general, where everything is connected and everything depends on other systems to work. And that, I think, is one of the main drivers of communications coming from outer space, right? From satellite systems, for example. And I believe that if we are to make an efficient exploitation of outer celestial bodies, we are to implement the same paradigm to make things as efficient as possible. And of course, this concept of Industry 4.0 is a driver of efficiency, and it needs space communications to be a reality. So I believe that the influx of capital and resources and people and excitement that we're seeing around space has a lot to do with that.
Yeah, maybe I was limited in my questions because I was talking about, talk about in orbit around the Earth, and we were talking about the moon, we should be talking about, as you just mentioned, going to Mars, going on, but beyond that, Tomas.
Yeah, exactly. Is what Stefano also made reference to, that the fact that we start in other planets much better than we started off here on Earth. Like, we learned from the mistakes that we already did, and for irresponsible maybe exploitation of resources and of nature in the past, and that we do it as efficiently and as cleanly as possible when we establish presence in other places.
So, Stefano, if I can come to you, what's your vision then for how these sorts of technologies could be used? I mean, do you think in 10 years' time we'll have settlements on the moon, that Alessia's satellites will be in orbit, we'll have Tomas's landers, we'll have David's antenna being reconfigured, and they'll all be serviced by Alessandro's satellites?
Maybe it will not be in 10 years, but this will happen for sure. This will happen for two main reasons. The first one is because there is a growing interest around the world. Whoever, you mentioned China that landed in the dark side of the moon, but there is India. There is, I mean, a lot of big and nations with money, of course, with money to invest, are running towards Moon and Mars. Last year there was the launch of Hope, that is the Mars lander of United Arab Emirates. Maybe 10 or 15 years ago, nobody could have imagined that United Arab Emirates could have launched their own Mars lander. So there is this sort of, let me say, movement around the world. And that means that the space agency and the institutions are really targeting at this and investing public money on that. Every time we say public money, we need to clarify the fact that this money are not wasted, because what you discover and what you test around the orbits, the Earth orbits, or on the moon, or whoever in Mars, sooner or later will be back in our daily life. There are plenty of examples we can do in our daily lives, that things that were tested on the Apollo, whatever, 11, 13, or on the ISS and things like that. So in principle, it seems to be something very fancy and maybe just wasting of money, but in 20 years from now, we will get back the results in our daily life. And the other thing is that due to this interest, there is also a commercial push. I talked about lunar economy. If there is a commercial push, it means that there is an interest from industries, and therefore there is a push in order to also invest from the industry point of view, because many of these things are not only public investments but also private investments. So we keep talking about PPP, public-private partnerships, because also the private, if they want to make business out of that, they have to put their money up front. I want to say one more thing about the growth of the interest in space-related themes. I think that this growth is directly proportional to the awareness of space in our life. Alessandro talked before about the usage of space data in our daily life, the communication, the whatever, navigators and things like that. The more people is getting aware that there is space behind all these things, the more interest in space is growing, also in the latest generations, and will keep growing. I'm very sure of that.
Let's quickly, before we finish, just quickly hear from our T-TeC participants one more time. Tomas, oh, hang on, I've got another question here. How could universities and industry could encourage, this is a question for Alessia. Let's just quickly get this question in. How could universities and industry encourage female presence in the space sector? Sorry to pick on you, Alessia, but it probably is the right question to ask you.
Okay, I try to answer it, but I think
You have
it's
to speak for all women here. How can we attract?
I have a lot of responsibilities.
Yeah, how can we attract more women into the sector? That's the question, really.
Okay, I think allowing the knowledge of the importance of this sector, bringing the knowledge of the how the opportunities that for the future. I think in university. It's important to know the future opportunity in the world of the future work. So
let people know, essentially, is tell people that it's there, and tell people that there are opportunities there. Really, yes. What Stefano was saying.
I think, for example, the promotion of a context like the T-TeC could helping to make to improve the confidential with this thematic in for everyone, so both for men and women. So.
Okay, excellent. The questions are coming in thick and fast now, and this is a good question here. I'm going to throw this at Tomas. Sorry. How far are we from being able to make a video call from the moon to the Earth? We can do it now, can't we?
Well, I believe that TV transmissions from the moon are a reality from the first Apollo mission. In fact,
exactly. Yes, exactly.
But if the question has to do with deployment of internet networks and the idea of making the internet protocol reach the moon, then I would say it will go in hand with general interest in investing and in taking presence and equipment to the surface of our natural satellite, right? But it will really, for sure be a reality when there is human presence there.
And it's building that. It's what Alessia was talking about, and what we were talking about is building that infrastructure so we could have a seamless video call with someone on the moon rather than have to wait till the visibility of satellites or receivers on Earth. David, this is obviously these sorts of technologies perfect for the sort of things that you're developing. Is it an exciting time to be sort of involved in space and getting, looking at these, thinking that things that you're developing, working on will actually get to fly?
Yeah, I mean, as engineers, our final joy is to see the things we have developed working. So of course that's a very exciting scenario for any development.
And Alessandro too. I mean, you were being very optimistic when we started this conversation. It's a good time to be doing your job, isn't it?
Yeah, I think it's a good time actually, and I hope, as I said, that we will be able to further develop our project, or at least what we call the enabling technologies, since our concept included a couple of technologies that are under development and that are extremely interesting to enable in-orbit servicing. So we are extremely positive on that, and we are going to work hard to make that happen.
Stefano, I'm going to give you the final question. We talked about, just before we came on air, we talked about, we'll hold the future T-TeC on the moon, we'll hold the future T-TeC on Mars. That's not an impossible dream, is it?
It is not. Well, it's a dream, but dreams are helping to grow. We are thinking about the next T-TeC for 2022. Not yet with the world ceremony on the moon, but we will see. We will see what will happen. I keep saying, joking of course, that in 2040 we will have the T-TeC world held on Mars. Of course, this is a joke, but we need to think big in order to reach all these targets that are complex, that are challenging, that are exciting. But we need to do that. When I say this, I have in mind what happened in 1969 when we landed with Apollo 11 on the moon, and I'm proud to say that the images talking about the video call from the moon, the images from the moon of the first man on the moon, of the first Apollo 11 LEM landing on the moon, were transmitted in Italy through our antennas in Fucino. That is something we are proud of, and that path, that thing started many years ago in just putting the first antenna in one small part in the middle of Italy, with anything behind, if not agricultures and things like that. So we started what is now the biggest civilian spaceport in the world, just with one antenna 60 years ago. And then we are here. So our fathers, who thought to start that, they thought bigger than what they had to reach at that time. And here we are, thanks to them as well.
That's a great final thought. Thank you all very much for joining me for this T-Talk on innovators in space. We had Alessandro, Tomas, David, Stefano, Alessia. Thank you all. Great discussion, really fascinating. How we're going to get to sustainability in orbit and back to the moon, and back to the moon to stay. Thank you all for your questions as well. And thank you for watching. I'm Richard Hollingham. Goodbye.